everyone! Welcome to the video to help you guys out with the Boyles-Charles-Guy-Lussac's combined gas law worksheet. So this is the very first worksheet of this unit besides the bookwork. So you should have already done the guided notes and the bookwork, and now we're looking at this particular worksheet. So the first few problems are pretty easy. I actually want to start right here with question number 3, because when you solve question number 3, you will be solving for an unknown on the denominator. Alright, so let's check out this question. They're starting you off with 25 liters at 10 degrees Celsius. They say that it is heated at constant pressure, so pressure remains constant, until it fills a new volume of 50 liters, and they're asking you for the new temperature in degrees Celsius. Alright, so what is the initial pressure? It says that pressure is constant. That was a trick question. So we don't have to worry about pressure in this particular question. What is the initial volume? Initial volume is 25 liters. And you hear this word at. That means that this volume right here is at 10 degrees Celsius. So this temperature, the initial temperature, belongs with that 25 liters. All right. They're looking for the new volume. So it says, they're looking for the new temperature, but they have a new volume. So the V final is 50 liters. And now they're looking for the final temperature. And make sure you understand that they want that final temperature to be in degrees Celsius. Alright, so the initial volume, the gas law that we're going to be using is V1 over T1 is equal to V2 over T2. These are the only two variables that they were talking about in the problem. The initial volume is 25 liters. The initial temperature was given to you in degrees Celsius, so we're going to have to do a real quick conversion into Kelvin. We're going to add 273.15. When you add, it's about the least number of decimal places. 10 degrees Celsius doesn't have any decimal places. This guy has 2. So when I give my answer in Kelvin, I'm going to only go to the ones place. So this will be 283 Kelvin. And I chopped off that 0.15. Alright, so make sure you understand that when you solve for this T2 on the other side, your answer will be given in Kelvin. Down here, we're going to insert the 283 Kelvin. The second volume is 50 liters, and we don't know that second temperature. Alright, there's a rule in algebra that says that you cannot solve for an unknown on the denominator. A lot of students, their knee-jerk reaction is to, when they're trying to solve for T2, is they're like, I'm going to multiply by 50. Do you realize if you multiply by 50, what you're doing is you're actually taking 50 squared. You're creating 50 squared on the numerator if you go 50 times 50 over here. That is the incorrect way to solve. So the best idea, and remember there's many different ways to go about this, the best idea here is why don't we do some cross multiplication just to see what happens here. So I'm going to take the 25 liters, and I'm going to multiply that by T2, and I'm going to set it equal to this guy, 283K times 50 liters. Alright, at this point we are going to isolate T2, and to get rid of this 25 attached to it, we are going to divide by 25. I'll come over here, divide by 25 liters, and you'll see that the liters cancel. And this is gone too. So T2 is equal to this. Alright, remember, when you solve for this answer, the answer is going to be in Kelvin. So I'm going to take 283 times 50 divided by 25. I've got 566. Remember, this is Kelvin. In order to go to degrees Celsius, we are going to subtract 273.15. Whoop. And the correct answer would be 292.85. Now, if you're careful with your sig figs, you'll know that that 8 is going to round the 2 up, and that'll make 293 Kelvin. Remember, when you add or subtract, it's about the least number of decimal places. Oh, whoops, that's not Kelvin, my bad. Degrees Celsius, sorry. All right, coming back here, we have some students that are interested in number 6. So we're going to dive over here and start problem 6. If you're in my IC, you get to pick which questions I do. All right. So it says an unknown gas has a volume of 200 liters at 320 kPa and negative 140 degrees Celsius. So all of that stuff goes together. That is your initial volume, your initial pressure, and your initial temperature. They all go together. All right, so this is 200. This is 320 kilopascals, negative 140. Careful, that's degrees Celsius. Okay, what is the new volume? We don't have our final volume, question mark, at STP. That stands for standard temperature and pressure. So this is a huge review. Standard temperature, ST, is 0 degrees Celsius. Standard pressure, SP, is 1 atmosphere. And you're like, wait a minute. In the problem, they gave us kilopascals. What do I do? Well, in class, I gave you guys a conversion. I said that 1 atmosphere is equal to 760 millimeters of mercury, but it's also equal to 101.3 kilopascals. I don't know if you guys remember that. So we have a stipulation that when we use the gas laws, the pressure unit has to be the same on both sides. So I'm going to use this 101.3 kilopascals, and temperature final is 0 degrees Celsius, but we're going to convert that to Kelvin, and so 0 plus 273.15 is 273 Kelvin. I need to fix that real quick, so I'm just going to change that to Kelvin. 273.15. Remember, that is a negative, so be careful. 273.15 minus 140. All right, looks like the initial temperature in Kelvin is 133. So don't use this. All right, you have a lot of variables to keep track of. We are going to be using the combined gas law. V1, P1 over T1 is equal to V2, P2 over T2. All right, so we lined up our formula, so we're just going to start plugging some stuff in, okay? So the initial is on the left and the final stuff is on the right. All right, so it looks like V1 right here is, here I'm going to scoot this over. V1 is 200 liters. P1 is 320 kilopascals. T1, we converted to Kelvin, is 133 Kelvin. So there's our initial stuff. The final stuff, I'm going to scoot this over. We don't have V2, the final volume. We do have the second pressure, and that's 101.3 kilopascals. And the final temperature is 273 Kelvin. All right, big algebra problem, huh? Here is our unknown, and we're trying to get that by itself. So everyone thinks of algebra in a different way. In the previous problem, I showed you how to do the cross multiplication technique. But let's see if I can get you guys to think of it a different way. So to get stuff to go away, you want to do the opposite of whatever you see. So over here on the right side, you see how 101.3 is on the top. That means that it's being multiplied. Do you guys see how 273 is on the bottom? That means it's divided. So if I wanted to get rid of those two, I would multiply by a really special fraction. See how this is on the bottom? Watch. I'm going to put it on the top. Do you see how this is on the top? I'm going to put that on the bottom. And just like in dimensional analysis, these will cross cancel. And you see how V2 is by itself? But since we have equal signs, whatever we do to one side, we'll do the same to the other. So I'm going to come over here, put 273 Kelvin on the top, put 101.3 kilopascals, kilopascals on the bottom. Alright, so let's take a look at what this will turn into. This fraction with the number on the top means that it's being multiplied. So anything on the top is multiply, anything on the bottom is divide. If I were to solve for V2 on my calculator, this is what I would type in. 273 times 200 times 320. Okay, that's all the stuff on the top. Now we're moving to the bottom. That means I'm going to switch to divide. 101.3 divide 133. And that will give us our answer for V2. And remember, that unit will be in liters. 273 times 200 times 320 times 101.3. Wait, sorry. Divide by 101.3. And then divided by 133. There we go. I'm going to double check my answer. 273 times 200 times 320 divided by 101.3 divided by 133. Okay. Looks like I got 1,296.8, and it keeps going. So looking at my sig figs, you know, this value right here, 200, is really only one significant figure. So I'm looking at my answer. I think what I should do is probably just reduce to one sig fig, which would be this guy, and he's in the thousands place. So I guess I'm going to have to round to say 1,000 liters. Final answer. And that is equal to V2. Alright, ladies and gentlemen, I hope that kind of gets you a start. And good luck. I hope you have a wonderful spring break. Don't forget that the optional extra credit assignment will be posted momentarily. Have a great time and stay safe.